Welcome back to the Exchange Server 2016 course on transport services, and in this module we're going to talk about transport high availability. Transport needs to be highly available as well, not just client access and mailbox database, but you have to do transport high availability as well. There's things that Exchange can do itself to make transport highly available, especially if you deploy a database availability group. But then there's also things that you have to do around Exchange to make it highly available that you don't forget. You shouldn't forget about those things and make sure that everything is in place and that you can still receive mail if you have some sort of disaster. So in this module, we're going to talk about transport high availability in general. We're also going to talk about site resilience and then how we implement that in Exchange Server 2016. So when we talk about transport high availability in Exchange, there's a couple of things that happens in Exchange, like shadow redundancy, that automatically does high availability in Exchange without you ticking one box or configuring one setting. It's enabled by default, and you can disable it if you want to. I wouldn't recommend that you do, but shadow redundancy is a great feature that allows you to that creates high availability automatically.
Yeah, it's really cool in the way that we introduced this in 2013, was it? Shadow redundancy?
No, 2010 even.
Back in 2010. But it's really neat how it just ensures that a message in transit, that there's a shadow message kept behind the scenes until that message in transit is received and acknowledged by the next hop.
Yes, so it's just a very clever way they work with the SMTP protocol to ensure that a message that is lost, maybe one server that's lost that had an email message in a queue, that message is not lost forever. There's another copy or shadow copy of that message. So it's a really good way of ensuring high availability. To talk about shadow messages, shadows are only done by the transport service. It's not done by the front-end service. So that's something that people need to know about shadow messages. The front-end service, which is basically on the same server, that doesn't queue any messages, so it's not doing
it's
any
just
shadowing.
It's just a proxy.
Yes. Yeah. Every message that is received is redundantly persisted, so it's shadowed. That's a fancy name for shadowed. Before the receipt of that message is acknowledged to the sender. So when I receive a message from another hop, I would only tell that other hop that, yes, I've received this message. You don't have to ever send it to me again. I will make sure that it gets to the final destination. I make a copy or shadow copy of that message to another server before I tell that server that I successfully received that message. If a shadow cannot be made, the transport service will reject the sender and it will give it a status code of 450, and it will tell that sending server that I couldn't accept that message, and then the burden lies with that sending server to retry again later to send the message again. The transport service, if it's part of a DAG, it will attempt to shadow this message onto another active server in another site if that DAG is part of a stretch DAG, and make so basically you have site resiliency as well then built in, so that's in that a copy of that message is on another server. And then the shadow server, so this is the server that's got a copy of that message, will then check every now and then for heartbeat and see if it will ask that server, have you successfully delivered this message to a mailbox or to the next hop, so that I can then disregard this message. And actually it doesn't disregard this message, it does something else with it, which we'll get into, and that's the safety net. But so it checks with that server to see if the message was delivered. If it wasn't, up to 3 hours, then it will try and attempt to deliver that message itself. So it will then say, well, I think that you couldn't deliver it, so I'm going to now send this message and make sure that it gets to the final destination.
If that happens, Martin, is there a shadow message of that shadow message?
Yes, that message now becomes part of the same mechanism, because that message is now promoted to a normal queue message, and that needs to be shadowed. So then Exchange will try and shadow that message again and to send it to the next hop. Okay. In rare cases, it might actually happen that the message was delivered, but then before the shadow server could check in with the server, something happened to that transport service and it couldn't do that check anymore. And now it sends the message again. And so now 2 messages are delivered to the store. But luckily, there's an algorithm built into the store to detect duplicate messages, and it will see through the message header ID actually to see that, oh, this message was delivered already, and it's not going to deliver the same message again. So users are not going to get confused with 2 messages in their mailbox. So it's intelligent enough to do that. So I have a architecture or animation here that shows you how the message are shadowed. So this is a mailbox server, 2016 mailbox server. A message comes from the internet. It goes to the transport server momentarily because it needs to just check that who to send it to, and then that message is copied or accepted to the transport server. That transport server immediately shadows that message to a server as part of the DAG in another site. So now there's a shadowed copy of that message. And then that message is delivered to the store. The shadow server would go and check through SMTP. So it does a SMTP connection to that server, and it will ask that server, did you deliver this message? And if it was successfully delivered, it will then move that message to its safety net. And the safety net is used for other purposes as well, but it's in the same process. So it then moves that message to the shadow or the safety net. So which brings us to the safety net. The safety net is part of this transport service to make sure that all the mail that goes to databases is also redundantly kept on another server. So in case you have to fail over to another database, if something happens to a database, that it will be able to redeliver messages that may not have replicated to the other databases.
Which can happen if you lose your transaction logs.
Yeah, so if you lose your transaction logs, if something happens to the power of that server and it wasn't able to replicate those last transaction log files to the other databases, then hopefully that's called a lossy failover. So there's some data missing. Then it will ask the safety net to say, do you have any messages in the last period that was delivered to the mailboxes that you want to redeliver? So that I don't lose any messages, so that there's no loss of data.
And folks familiar with Exchange 2010 probably remember safety net being referred to as the dumpster.
Yes, so this was the transport dumpster. So now they incorporated this concept of the shadow queue and the safety net into one, and they basically serve both needs with those. You can set up various settings with your shadow and safety net. So there's a bunch of commandlets. If you look at the transport config, you can enable and disable shadow redundancy, and you can look at the safety net settings inside of your Exchange system, like the safety net hold time and so on, that keeps the safety net information up to date. So let's move on to site resilience. Site resilience in Exchange Server 2016. So again, this is really important that you need to plan your site resilience and define your requirements for site resilience. If you have a disaster and your mailbox service is down and you want to fail over to another site, because this is site resilience, you need to look at what is the requirements. I'm going to fail over to this site, so I have to have redundant ISP links. I have to have network links that allow SMTP connections to come into that other site so that you can accept mail still. I need to be able to send out mail still to the internet, so the configuration to allow that also needs to be possible. So there's many things that is required. So again, it's important to plan this, and I can't stress this enough. You need to plan your site resiliency, because unless you know and sort of think what can happen, what's the disasters that might require me to fail over to another site in terms of transport, you're not going to be ready for it. So you have to think about all of the scenarios that can happen, and then how you're going to resolve that using Exchange configuration.
You need to plan for MX records, send connectors. If you do want to capitalize and take leverage of those transport high availability features we talked about, shadow redundancy and safety net, then the DAGs that you deploy need to be, your members need to be distributed across the sites, as opposed to having a DAG in one site and then another DAG in the other site.
Yeah. So if you have a DAG just on one site and that site is down, then obviously you cannot fail over those databases to the other site. So that's a good reason to spread those DAGs across sites and make sure those databases are available on that side, and the transport services and the queues are also available on that side. And as we mentioned previously, when you have this DAG that is stretched across sites, then shadow redundancy will make sure that the messages are shadowed to the other site as well. To implement site resilience, you have to think about your client access considerations as well, all the settings around client access. And so the clients that, for example, submit SMTP messages, will they be able to resolve a name that will get them connected to servers in the site resilient site? If they are configured with a name that resolves to a server that's in the primary site that's down, then those clients will not be able to send mail. So you have to think about how DNS resolution will happen in those scenarios where the primary site is down. Then you configure the site transport site resiliency by stretching the DAG across the sites, and so you have transport site resiliency. You configure the multiple MX records. Maybe the secondary site has got a lower priority MX record, so it's not 10 or 100, but it's got a higher value, which means that it's got a lower priority. So with MX records, it always uses the first ones that it gets with the lowest number, and then if those don't work, it will try the others. So that's how you configure external site resiliency. You can also use resubmission queues. So you can export, so if connectivity is down in your primary data center, you can export messages from that primary site. Say the servers are up and running, but it's just a network connectivity to that site. You can then export messages to a portable hard drive, and then get into your pickup truck and drive to the other site, or get into a plane and then import those messages again to get them delivered to the mailboxes and or to get them delivered to the outside wall. I've been in many organizations where the mail queues are constantly thousands of messages in there because there's so many messages that are being delivered. So that could be critical data that needs to be saved. So if those messages were waiting to go out, maybe you want to export them and take them to another site so that you can get them in that site so that they will be delivered out to the internet. When you do a site failover process, maybe you want to do that manually so that it doesn't, it's a DR situation, so now you're going to fail over to another site. You want to think about, how do I achieve that? Am I going to update DNS records so that DNS resolution happens? When you update DNS records, you have to think about time to live values, because DNS records are cached by other servers on the internet. And if your time to live values are high, set to 4 hours or something like that, then updating DNS may take 4 hours before the servers trying to send you will know what's a new IP address before they can send mail to the site resilient site. So you have to maybe beforehand lower those time to live values on DNS so that the switchover can take place quicker. So that, in a nutshell, is really the site resilient options of Exchange transport. There's many other things that you need to consider as part of this. And again, I would remind people to look at the edX course and look at all the configuration settings that you can set to make sure that your Exchange system can always deliver mail when you have site resiliency. Thank you.